Imagine this carefully. Two photons are created together and fly apart in opposite directions. Before we measure them, neither photon has a definite polarization. Not vertical, not horizontal, nothing is fixed yet. Now the problem appears that we measure the first photon. The result is completely random. But the moment this result appears, the outcome of the second photon is already determined, even if the photons are separated by an enormous distance. This is not about sending a signal. Nothing travels between the photons. No energy is exchanged, that no information is transmitted, and no time delay is involved. And yet, the results are perfectly correlated. How can the second photon already know what result to give? This question is known as the EPR paradox. Einstein argued that either reality is incomplete or something fundamentally impossible is happening. Light has a definite polarization, and nothing can influence something else faster than light. This principle is called locality, and Einstein believed it was a fundamental rule of nature. Quantum mechanics tells a very different story. In quantum experiments, a single photon can split into two. These photons are called entangled. They are not independent objects, but parts of one shared quantum state. Before measurement, neither photon has a definite polarization. Instead, it defines only how the measurement outcomes are related. But once this result appears, the outcome of the second photon is fixed instantly, no matter how far away it is. No energy is exchanged, that no information is sent. Einstein believed the result must have existed all along. He proposed that each photon carries hidden variables, predetermined instructions that specify the outcome for every possible measurement. In that picture, reality would remain local and complete. Niels Bohr strongly disagreed. Bohr argued that measurement does not reveal pre-existing properties. Instead, measurement plays an active role. It defines the physical outcome. According to Bohr, the photon and the measuring device form one indivisible system. Physical properties, in this view, depend on how we choose to measure them. For decades, this disagreement remained philosophical, until physicist John Bell changed everything. Bell showed that if Einstein's hidden variables exist, the correlations between measurements must obey strict statistical limits. Experiments tested these limits, using entangled photons and different measurement angles. The result was unambiguous. The correlations violate Bell's inequality. Again and again, hidden variables do not exist. The photons did not exchange information faster than light. They were never independent systems to begin with. Only the joint quantum state is real. Einstein asked the right question, but nature chose a stranger answer. Reality is non-local.